Okay, so let's continue. We talked about consecutive interior angles, namely angle 3 and angle 6. They're interior of lines M and they're on the right side of the transversal. So they're consecutive interior, so on the right side there of the transversal. So let's continue. So for the next angle pair, we've got exterior angles. Angle 1, 2, 7, and 8 are exterior because as we can see hopefully here, they are outside of line M and N. We call them exterior again for that reason. Next, alternate exterior. And I'm going to erase, let's erase 1 and 7. So 2 and 8, those are technically alternate exterior. Again, alternate. The idea is on either side of the transversal, but also exterior, so alternate exterior. And there's also, of course, two others, angles 1 and 7. Angles 1 and 7 are also alternate exterior. So we have alternate interior, 3 and 5, 4 and 6. Alternate exterior, 2 and 8, 1 and 7. The last type of angle relationship that we need to take a look at here is corresponding angles. Corresponding angles are interesting because they are on the same side of the transversal. So for example, angle 1 and angle 5. They are not, in terms of where M and N are, they're not interior nor exterior together. However, they're both on kind of the part of the line that, if you were to look at it, are above line N and above line N. The way I frame this to kids when I first show this is I show how this kind of shape, it's almost like the letter F, if you kind of take a look here. So above and above, but also to the left. So angles 1 and 5 are corresponding. So are 2 and 6. So are 3 and 7. And so are 4 and 8. So let's take a look. Example. So classify the relationship between each pair of angles as alternate interior, alternate exterior, corresponding, or consecutive interior. So angle 10 and 16, so here and here, those two angles are, thanks to the transversal Q, they're alternate, but they're also exterior of lines N and L. Part B, we've got angles 4 and 12 to take a look at. So angle 4 and 12. Now I would consider this where N is the transversal, and therefore, and I'll use my little kind of notation for the notation for that F shape, kind of like we saw up above. That's the notation. So 4 and 12 are on the kind of left side of both lines P and Q and down below transversal N. Letter C. So those are corresponding, like I said, on part B. So letter C, angles 12 and 13. So here's 12, here's 13. Those two angles are interior to N and L, and they're consecutive, meaning they're on the same side of transversal Q. Last but not least, angles 3 and 9. If you take a look, 3 and 9. Okay, I would argue that these are alternate because they're on either side of the transversal N. So alternate. And they're interior, in other words, inside of lines P and Q. So alternate interior angles for those two. Okay. We're going to go ahead and continue. Not in section 3.1, but we will in section 3.2. But before I do that, I do urge that you take a look at some of those problems there on page 6. The remaining questions, numbers 1 through 12, use the figure in the example above to do those. Please cross-reference, because this is going to be easy enough where you can probably do this, without me fully describing it. So please cross-reference using the answer key as you know how via on your content library in the answer key section right here. All right, so like I said, I'm going to continue my discussion here with section 3.2 in part 2 here. Part 1 was mainly 3.1, part 2 is mainly 3.2. Parallel lines and angle pairs. When two parallel lines are cut by a transversal, the following pairs of angles are congruent. So parallel lines, we have a transversal. Corresponding angles are congruent. Alternate interior angles are congruent. And alternate exterior angles are congruent. So let me draw two lines. And by the way, do your best to also draw them as parallel. Just for the sake of argument and making a connection to one versus the other. Here's line A, line B, and I'm going to mark them up as parallel, which you should also do with those little arrows as I described in part 1, and then draw a transversal, which I'm going to label as T. So corresponding angles are the following, and I probably should also go through a number. Numbering the angles is not necessarily as crucial as we go through this just initial process. Later, though, it will be crucial. So corresponding angles will end up being, let's see, angle 1 and angle 5. Those two angles are corresponding, therefore they're congruent. Okay, what else? Well, turns out so is 8 and 4. Okay, so is 7 and 3. So is 2 and 6. Now, actually, what I've just done is I've not just highlighted the corresponding angles congruent. I've also highlighted the other angles, particularly as we go ahead and take a look. Alternate interior angles, angles 3 and 6. Angles 3 and 6 are alternate interior and they're congruent. 4 and 5, alternate interior and they're congruent. And there you have it. Alternate exterior, that's next. Just like alternate interior, look, angle 1 and 8 are alternate exterior, therefore congruent. 2 and 7, alternate exterior, therefore congruent. The only other thing that isn't listed here are vertical angles, but we already knew that from a prior chapter. Angle 1 is congruent to 4 because they're vertical. Angle 2 is congruent to 3, 5 is congruent to 8, and 6 is congruent to 7. Again, all because they're vertical. The only exception to congruent relationships is what you'll see here in the next statement of supplementary. So consecutive interior angles will always be supplementary in the context of comparisons. In our analysis from above and in our comparisons now, we can see, for example, 3 and 5. Angle 3 and 5 are consecutive interior. Again, they're inside, so to speak, line A and B, and they're that's interior, and they're consecutive because they're on the same side of transversal T. So angle 3 plus angle 5, which is something I can show very quickly, I believe. Angle 3 plus angle 5 should end up being 180 degrees. Okay, because that's the definition again of supplementary. And the same is true with angle 4 and 6. Angle 4 plus angle 6, the measure of angle 4 plus the measure of angle 6 should equal 180 degrees. Okay, so as we continue in the example, in the figure, the measure of angle 2 is 75, so let's mark it up. You can draw that picture, of course, and I would recommend you do that in your notes spiral. And what? It says find the measures of the remaining angles. So when you do a problem like this, please right away highlight the fact that M is parallel to N. Now the picture shows the arrows, but that's important to kind of highlight as you go. And from there you can quickly and easily say, okay, well 2 must be congruent to 4 because they're vertical. So this is also 75. Well heck, so is 6 because it's alternate interior to 4. So angle 4 and 6 are 75. Therefore, so is angle 8 because it's vertical to 6. So all I'm doing here is I'm filling in everything I know, and I would do that as soon as possible, because then when you go through and finish, you're really having just the picture to guide you. This is going to be supplementary to 75 by virtue of linear pair. 180 minus 75 is 105. So not only is that 105, so is that, so is that, so is that. Okay, so I've noticed I've marked them, and I actually did that in the prior example very strategically because I wanted you guys to see. I wanted you guys to see by the visual side of things. If I could make my notation, that's okay, I think. I have a single marking and I have a double marking. The single marking tells me that it's 75 degrees. The double marking tells me that it's 105 degrees. Now I didn't fill in 105, but I'm sure you guys can figure that out, or maybe fill it in later if you have more space. I don't have enough space. So here we go. Angle 1 is 105. Linear pair is the connection to be made. Angle 3 is also 105, linear pair. Angle 4, if you look at the picture, vertical angles. Angle 4 and 2, for example. 105 is the measure of angle 5 if you look at the picture again, and this is because alternate interior angles, as the what angle 5 and 3 relationship shows. 6 and 2 are corresponding, so angle 6 is 75. We have 105 for angle 7. If you look at the picture, we know this again because corresponding with 7 and 3. Okay, maybe I'll use that quick depiction of that kind of shape again that's forming. So that's the corresponding angle relationship. And then last but not least, angles 8 and 6 are vertical. You didn't actually have to describe why exactly in the same way. I mean, you could have literally just said, instead of angle 8 being 75 because it's vertical to angle 6, you could have said angle 8 is 75 because it is alternate exterior to angle 2. All right, so angle 2 and angle 8 are alternate exterior. So there's a whole variety of sample reasons that we could technically answer on that type of question. Okay, so I did fill in the answers for the rest here, and I do want you to take a look at those. I'm going to pick some select questions, particularly, let's say, how about for number 1? Looking at the figure, we've got angle 3 as 102, okay? And therefore, we know, well, this angle should be hopefully congruent to its vertical angle at the very least. What I didn't say, and I will go back for the moment, I will say that these two lines are parallel, which they show in the picture. And that's a big deal. If the lines are parallel, listen very carefully, if the lines are parallel, then all of these statements from up above, if parallel, then all of these conclusions really help us define why they're congruent, or they are congruent is the finishing kind of statement there. So if lines parallel, then corresponding angles are congruent. So I actually just used quite conveniently, I used an if-then statement to help understand why things are framed in this manner. So on number 1, angle 5 is 102. Angle 1 is 102 because they're vertical. However, if we go back and look at this idea, angle 5 and angle 3 are alternate interior. So one could actually say, for this particular reason, if lines are parallel, okay, if lines are parallel, and I'm going to add the nuance of this notation. You don't have to do that necessarily, but it's nice to kind of help connect the dots, so to speak. Then alternate interior angles congruent. So with that problem being the last one for the day, I would like you to look through all of those remaining problems on this page. I do also want you to take a look as a preview, so to speak. I want you to try this example just to see how things are going to shape up for our next day. Go ahead and conclude that, look at things on your own, and like I said, cross-reference using what I've completed, but also the answer keys.